Hello everyone, welcome to this online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. As we are discussing in metal forming, so two lectures already we have completed. Today we are going to discuss this closed die forging. So today's lecture will cover closed die forging. Open die forging we have already seen, and also we have seen what is the ideal condition, what is the real situation, and accordingly what will be the effect on the deformed material. So today we'll see what is the meaning of closed die forging in detail, and also we'll see flashless forging, and of course we'll take some numerical based on this forging operation. So we are starting with the closed die forging. Closed die forging at the starting itself, I told in last lecture that in die material will not be free to move. Means in transverse direction it is not going to be free to move. In the case of open die forging, when we are applying the force after deforming, when material will start to flow inside the die, there was no constriction, there was no restriction in material flow in transverse direction. But here, in the case of this closed die forging, material will not be free to move. Okay. So what will happen when we apply the force, when we'll deform the material, it will be its flow will be confined in the die or in the cavity that provided there in the die. So what will happen here in the diagram, you can see three diagram has been shown. This is the lower die and this is the upper die or lower platen or upper platen. This is fixed, this is also fixed, this is fixed. Okay, so what is happening? This is the workpiece and this is the upper die. So you can see here a impression is provided in the die. This is the impression. This is the impression in the upper and lower die it is provided. So what will happen once we'll apply the force, suppose from the top of we are applying the force, metal will start to deform. So here it is deforming. This is the intermediate position. This is the starting and this is the intermediate. So what is happening? If we'll observe slowly because of the deformation as it is flowing inside the die, so it is taking the shape of whatever the impressions are there in the die. So as material is deforming, slowly it is taking shape of the die contour or the die impression over there. So it is not free to move. It is not free to move in transverse direction. Rather, it has to move inside the die impression hole or a die cavity. And finally, when the compression is completed or the deformation is completed, it will take the shape of the die inside or die uh, shape whatever is from the inside it is there, it is going to that whatever the impressions are there, it is going to take that impression. So finally you can see here, obviously some flash means a material will come out from there, but it will take the final shape. So this was the shape that was set at the starting in the die. You can see finally after final deformation we can see that material has taken the shape of this die or impression of this die. So unlike open die forging, here it is restricted that in what area material can flow and in what area material cannot flow. Okay. So in closed die forging, this is also known as impression die forging, performed in die which has impression that will impart it to the workpiece through the forming. Yeah. So whatever the shape or the impression that has been already given in the die cavity or a die after deformation material is going to take. We can see through the diagram also. Here this was the shape. So finally the material has taken the shape of this die impression. In the intermediate stage, this intermediate stage, initial billet deforms partially giving a bulge shape. Obviously, here is the bulge shape. You can see here the bulge shape. During the die full closure, impression is fully filled with the deformed billet and further moves after the impression in the form of flash. Yeah. So here, of course, there will be bunching in intermediate, but finally, when material is completely deformed, it will take the shape of the impression die. A little bit amount of material, of course, will be appear in the form of flash over there. But finally, material is going to take the shape of the die. In multi-stage operation, means different stages are there. Separate die cavities are required for shape change. Yeah. In the initial stages, the uniform distribution of properties and microstructure are seen at the starting. In the final stage, actual shape modification is observed when drop forging is used. Several blow, yeah. If it is not in one stage, if multiple stages are being used, then multiple times through the hammer or the this blow. Multiple blows will be required to deform the material completely. So impression die forging is not capable of making close tolerances. Obviously, it will not be there. You can see here something will be there that you need to be trim out. Okay, now so close tolerances of the object will not be there. Machining generally is required to achieve the accuracy needed. So whatever the materials has come out in the form of glass or other impressions are there that need to be removed through the machining. So the basic geometry of the part is obtained from the forging process, with subsequently machining done on those portions of the part that require precision filling like holes or threads. Yeah. So means if we are forging the material, we are forging the material through the closed die forging. So secondary operation that machining is required. But if precision forging is there, this precision forging nowadays, precision forging is there. In that you don't need a secondary operation. So in order to improve the efficiency of the closed die forging, precision forging was developed that can produce forging within sections. Means more complex geometries, close tolerances, and elimination of machining allowances will be there. Meaning single pass, you don't need to do the secondary operation over there. In single pass, part will be completed, and whatever the product that will produce over there will be near neat shape forming. Okay, now so here in closed die forging also there will be no requirement of the secondary operations like machining. Now this flashless forging, that is the third of this we classified. So flashless, as the name is, there will be no flash in this one. Means the three stages we have shown here. Suppose this is our material that we are going to deform. This is the punch through which we are going to apply, and this is our die. So finally, it will take the shape of this die. Okay. So this is the intermediate stage. The bulging will be there, but finally, if we will see, it has completely taken the shape of the die, and there is no flash over there. Means there is no extra material that has gone away from the die. No, that's why it is flashless forging. Okay. So in flashless forging, most important is that workpiece volume must be equal the space in die cavity within a closed tolerance. This is very important to understand. Workpiece volume must be equal the space. You can see here whatever the material are, anyway it is not coming out in the form of glass. So whatever the volume of the material is and volume of the impression of the die or the volume of the space provided in the die, both should be equal. Then and only then there will be no flash over there, and whatever the volume of the material is, it is going to take the shape of that particular die or impression of that die. If the starting billet size is too large, excessive pressure will be cause damage to the die and press. Yeah, obviously. That is obvious. If dimension is very large and you are applying, so definitely die may be or punch may be damaged. If the billet size is too small, the cavity will not be filled. Yes. If material is not sufficient, the size is very small, so it will not be sufficient to fill the die over there. Because of the demand, this process is suitable to make simple and symmetrical part geometries and to work materials such as aluminum, magnesium, and there, especially soft metal, which is very easy to deform, especially like aluminum and magnesium. So this process is generally used for this kind of metal, which is very easy to deform. Okay. Next, we'll take this one of the example, this coining, one of the example of this impression die. So for that, as an example, we have taken this one. So coining is a simple application of closed die forging, in which this is just example to just show you. We have taken this one. Have taken this one. So closed die forging, in which fine details in the die impression are impressed into the top and or bottom surfaces of the workpiece. Through there is little flow of metal in the coining. Although there is little flow, coining you might have seen, only little flow of material will be there over the bottom of the surfaces required to produce the surface detail in die cavity at par at other impression forging. Because what is the mean? The pressures required to reproduce the surface details in the die cavity are par with the other impress. Although here the material flow is very less, but impression that reproduce the surface details in the cavity are far if we compare with the other processes. You can see here stepwise we have seen this is our blank or this is our workpiece, and just see the impressions provided in the die. This is the upper die and this is the lower die. Okay, na means this is punch. So what it is going to do, it is going and coming and striking here. So just see here, whatever the impressions are there, whatever the impressions are there, that is going to be imprinted in the workpiece. So this is our blank. So finally it is coming straight from the both sides. So you can see here completely it has taken the shape of that one. Although material flow is very less, but look at the impressions over there. Different impressions are there. That had been written here. Reproduce the surface details in the die cavity are at par with the other impression processes. Although material flow is very less, but look at the impressions. Okay, and finally this is the finished part. So whatever the impressions are there, that has been completely imprinted over there on the workpiece. Okay, next we are going to take this numerical based on this process. And so what this process is, this is also based on true strain. So what I told at the starting, if you have seen the last video, that true strain you are calculating, it doesn't matter whether the forging has been done in single a pass or it has been done in multiple passes. What you have to keep in mind, whenever you have to calculate the true strain, you have to take consider the initial, what was the initial dimension of the piece that you are going to deform, and finally after deformation, after multiple deformation or progressive deformation, what is the final dimension. Because to calculate the true strain or total true strain, only these two things are required. Okay, if this is there in your mind, what I told in last lecture, then this numerical is very easy to solve. So now we'll read and try to solve this. A rod of length, so initial length, this is the Li, which is given 20 mm, is stretched to 40 mm. This is the intermediate dimension. So we are writing this intermediate INT. Okay, as this is a progressive, so it has become 40 mm. Okay. Subsequently, it is compressed to 10 mm length. So finally, the final length has become 10 mm. So what was the initial length? It was 20 mm. It was forced and length increased and it became 40 mm. Then this 40 mm piece is again forced and finally the length become 10 mm. Now what we have to calculate? We have to calculate one assumption is given, consider longitudinal strain as positive and compressive strain as negative. This is the sign convention which has been given. Calculate total true strain. So we have to calculate the true strain. Okay, what is the true strain value? So if you remember at the last lecture when we solved one numerical, I told either it is a single stage processing or it's a progressive deformation. What you have to keep in mind when you are calculating true strain, what you have to keep in your mind, that you have to consider the initial dimension and you have to consider the final dimension. You don't have to bother about the intermediate dimension. So this is anyway is not required to solve this numerical. Okay, what I need, this is the initial dimension, and what I need, this is the final dimension. So what is the formula for the true strain? The true strain formula is ln final length upon initial length. Okay, and what is the final length? Ln means natural logarithm, and what is the final length? That is given 10 mm. Okay, and this is given 20 mm. Okay, so this will be cancelled out, so simply this will be ln half, and the value of ln half is, what is the value of ln half? This will go, it will come negative, so it will be simply, we can write minus ln 2. And what is the value of this one? It is negative, simply minus 0.693. This is the value, this is the answer of this one. So what is the total true strain during this progressive? This is negative of 0.693. So we'll stop this lecture here, and next lecture we'll come up with some other metal forming processes. So thank you.